Now we're going to move on to modular JavaScript. So the first part of this presentation has all been about sort of getting people who perhaps don't have the best knowledge about structuring small to medium-sized apps up to speed. Now, if you are experienced, if you have been using Backbone, if you have been using any of these other structural solutions, and you want to start expanding into something that's going to scale a little bit better for you, you have to remember there are other concerns, like modules, for example. Modules don't fit into MVC. It's not really a model, it's not really a view, it's not really a controller. It's a unit of code that I might want to reuse in other parts of my application, or in other projects even, ideally. So let's take a look at our options for modules in JavaScript. So, how many people here know what an object literal is? I assume quite a few. Okay, a lot of people know what an object literal is. If you don't know what an object literal is, just consider it this particular part of what I'm going to talk about. It's essentially an object which contains key value pairs, and you can use it to basically structure a block of code, a unit of code, into a sort of module. This is the module pattern in JavaScript. And it doesn't differ that much from the object literal, except we try to introduce this idea of privacy. In other languages, like perhaps Java, you have this idea of, some part of your code or your module can be private, and it's not exposed to the entire world. And then you have a public API which you return to people. And the module pattern is all about that. It lets us define some private stuff up here. This can be variables, it can be functions, and that's private. When I say private, however, it's important to remember something about the JavaScript programming language. It has no access modifiers. There's no true sense of privacy. We try to simulate this so that we can get a sense of structure in here. But really, the whole idea behind here is I'm not exposing any of this code to the rest of the world, but I am exposing all of this. The rest of the world is going to be able to use add item and get item count and get total, but they won't be able to directly access the basket. And this can be used. This can be used to construct some fairly basic module constructs. But there are some problems and some limitations with this. Let's say I wanted to develop an application where I'm dynamically loading in modules depending on what somebody does. How many people here use Gmail? I'm assuming most of us. We're developers. There has to be more people than this. Oh, come on. All right. I'm assuming a lot of people here use Gmail. Gmail is perhaps the greatest modern-day JavaScript application that's out there. There's a lot of engineering work that goes into it. And if you ever notice, in some cases when you load up Gmail, the chat widget is actually minimized. And it's interesting because they don't actually have to load up any of the code to do with that chat widget on page load. If somebody actually clicks on the maximize button, they can dynamically pull in all of the code for that, meaning that they can have a quicker load time on when someone first visits the application or when someone just wants to log in and check their email. If they wanted to save configurations and say, okay, well perhaps someone always wants this open, they can load in that particular module on page load, but they have the flexibility to do all these things that they want. Not much trouble. Now, JavaScript's simple module pattern doesn't really give us that. So let's take a look at what's going to be out in 2013. I'm going to be showing you some samples from ES Harmony, or es.next as some people like to call it. This is going to be the next version of JavaScript. So the next version of JavaScript is going to come with some slightly smarter modules. Here's a module which I'm simply defining using the keyword module. I'm able to import dependencies from other modules. So if I had a module called widget, I can import some dependencies from that. If I define something inside here, it will actually be private. It won't just be me simulating privacy, it's actually going to be private. I then have this concept of exports. Now exports are very similar to what you saw in the last slide with the regular module pattern. You're returning something for the world to use. And that's what the concept of the export lets us do. So the module format proposed for Harmony has goals like static scoping, simplicity, and usability. I think this is better than what we have right now. And it gets better. You can do things like load up modules from within your code. I can load up modules from external sources. So if I wanted to load up a module called cakes.js, all I have to do is say module cake factory is what I'm going to alias it to from whatever, and then I can start using that. That's just one line of code. How cool is that? And then if I wanted to dynamically pull in different dependencies, I can use the module loader API. I can say loader.load, the same thing, and I can start using it. This stuff is extremely powerful, but it's not exactly easily accessible in JavaScript as we know it today. And then eSHarmony also tries to target people who like using CommonJS or CJS modules. I'm not going to go into CommonJS in great depth. It's essentially another module format that is somewhat optimized to server-side development. But these are modules that you can write in JavaScript and they'll work on the server. Here I'm writing a file.js file which is going to be doing some I/O work. I've got a lexical handler which is basically just going to import some other dependencies. In this case it looks like it's actually going to import a specific function from my module called file. I'm going to define some more exports and then I can start reusing this, and this is all on the server. This stuff's great, but I don't want to wait 2 years to start using any of this. Especially the stuff I just showed you about dynamically loading modules or being able to easily do, where are we? Easily structure things in a way that I can import dependencies without having to worry about structuring a solution that lets me do that. So I'm going to talk about AMD a little bit. How many people here have used AMD before? So we've got 2 or 3 people in the room that have actually used AMD. So AMD stands for Asynchronous Module Definition. And it's a solution which tries to give us a better module format for JavaScript that we can use today. It has a mechanism for defining asynchronously loadable modules and dependencies. It has non-blocking, parallel loading, and well-defined aspects to it. And it's considered a stepping stone to eSHarmony. So a lot of us consider AMD to be a temporary solution. But if you want to start writing more powerful modules today, it's better to use this than it is to just wait until eSHarmony, first of all, gets finalized and then starts getting implemented by different vendors. So AMD has 2 major concepts. It's got a concept of a define, which allows you to define new modules. And this is the signature for it. So what you'll see is a define ID, dependencies, and then a factory function for defining your actual module. Now if you don't supply an ID, that's going to create an anonymous module. You can create named modules if you want. It's not necessarily advocated as best practice. But I'm going to include a module ID just to show you how this works. I can define a new module with a specific name, so it's easy to reference in other modules. I can define an array of dependencies. I don't even have to actually type in .js at the end of these things. It'll automatically take care of all this stuff for me. So foobar and foobar are 3 dependencies that are needed for this particular module. Then I'm going to have my actual export. So the same idea that we had before of exporting something that the rest of the world can play with. I've got the same thing here. And notice that I'm actually aliasing all of these dependencies that I'm loading in that can be accessed using these variables foobar and foobar. So I have a module object, and then I can start adding different functions and different variables onto that module object and just return it. That takes care of things like dependency loading. That's fine. Let's say we wanted to dynamically load dependencies. Let's say you wanted to do something like Gmail and not actually load something until a user says, well, hey, I actually want to use this, which makes sense, especially when you're building slightly larger applications. So you can use a require for that. Typically, it's used to load top-level JavaScript files and modules, and this is the part of the code that you want to be paying attention to. So we have a define that's defining the rest of our module, but we're actually pulling in other dependencies dynamically here. We're pulling in, let's just say again that the dependencies we want to read in are foo and bar. All I'm doing is defining a variable at the very top. It's a Boolean check saying false. Once these dependencies actually load, I'm just going to say that's true. And then I can actually return the state as well as parts that I've loaded in from other modules. This is all dynamic. Again, meaning that you don't have to worry about loading all this stuff up on page load, which improves performance. So AMD modules, in order for them to work, actually require you to use a few different solutions. You can be using require.js. Require.js is what I use when I'm using AMD at AOL. You can also use John Hand's curl.js. It does the exact same thing. It's a script loader which supports AMD. And if you're considering why you should care about AMD, a lot of these solutions are using them. Dojo is now basing its latest versions on AMD and the idea of defining modules using the AMD module format. MooTools, the next version of MooTools is going to support it. jQuery, we currently support some aspects of AMD. So, because I like using require.js, I'm going to talk about it very, very quickly. So, we don't really have a clean way to import stuff in JavaScript. If I'm inside a script file and I want to easily import stuff, I want to import 30 different dependencies, all of which have perhaps their own dependencies, and it's a slightly complex structure. There's no easy way for me to do that. Require.js through AMD gives us the ability to do this. It allows us to easily load nested dependencies as well. And it has an optimizer for packaging scripts to avoid excessive HTTP calls. So one of the things that I mentioned was script loaders. Now, not everybody actually likes using them. Some people will say, well, just including 10 or 20 scripts on my page isn't going to kill my browser. Well, if you use the r.js optimizer that Require.js comes with, you can start bundling up parts of your scripts that are not going to be dynamically pulled in. So if you're going to have perhaps a backend application that you structure using AMD, you can pull in your default views, models, and controllers just using Require.js and r.js, and it'll bundle all of those into a main file. And then you can have any dynamic dependencies being pulled in later on as needed. You can also define your own jQuery modules using this. You can also define, not only can you do this, you can actually define jQuery plugins using AMD if you want it. And they can inherit from other jQuery plugins, which is all sorts of cool. I'm not going to show you that stuff, but it can get really, really awesome. Here what I'm doing is I'm pulling in jQuery, the jQuery color plugin, and the jQuery bounce plugin. And I'm aliasing jQuery to the $, so I can start using it in here. Now, another reason why it's useful to use AMD is because it protects you from the global scope. You don't have to start worrying about things leaking that are being executed inside here. But I'm able to use this in a very, very sort of succinct, readable manner, I think. And there's other stuff we can do with it as well. How many people here know about the concept of deferreds? Okay, we've got five or six people, right. So the idea behind deferreds is that, actually let me try explaining this quickly in a good way. Right, so let's consider that a lot of us are developing applications using Ajax, right? And one of the problems with Ajax is that you actually have to wait until an asset that you're loading up has finished loading before you can continue with the rest of your application. And that's considered a blocking action. It's actually going to block your interface while it's trying to load that up. The idea behind deferreds is that you can actually just return a promise instead. And you can send a promise to your application and say, okay, well, I promise to let you know when this thing is finished loading. That's essentially the concept of a deferred. And you can apply that to AMD modules. You can use jQuery deferreds if you want, or you can use defer.js or any other of the other solutions that you do this. But the idea is that I can actually say, okay, well, I'm not going to let anything else in my application continue. I'm going to allow this process to complete itself before continuing on with anything specific. I can show a loading message to the user if I want to. I can go and let the user interact with my application in other ways. That's useful, again, in a Gmail-like application, where you can actually compose something and have it sending in the background. This type of behavior lets you do that. And one other thing that I love using Require.js for is externalizing my JavaScript templates. A lot of you are going to be developing applications where you might be using a templating solution, whether that be handlebars.js or underscore templating or mustache.js or whatever. And one of the problems with that is that we end up defining a lot of our templates in line, in the same index file, the same markup file as the rest of the presentation layer for our page. And that's not necessarily a good thing. We should be able to split these out and maintain them as if they were separate files. And using Require.js and the Require.js text plugin, you can actually do that. So all I need to do to load up that plugin is just use text, an exclamation mark. I can define a HTML template, and that can contain any of my logic, my template logic in there as well. I can then alias it to a variable, like that. And this is Backbone. All I need to do then is just pass it in to whatever templating function I'm using in my application. Here I'm using underscore micro templates. I could be using a slightly different templating solution, and it would be more or less the same. I'm just passing in the content of my template and allowing my application to then start using it. And this is extremely useful when you're developing larger applications, which are going to contain more than 5 or 10 templates at least. I'm very going to quickly sort of cover some of the misconceptions with AMD. If you start reading about this stuff, especially the more recent stuff about it, there are some people in the community that feel that it's not a good solution, or that it's a solution that's not worth trying out. Some of the arguments are that ES Harmony are going to cover these things. The response to that is people don't want to wait 2 years. We're developers. We want to start using the cool and sexy right now. define wrappers. So all those little define lines that I showed you, those do mean a little bit extra code. It's essentially 2 lines of extra code per file that you're wrapping in that module format. I don't think that's a lot of cost. Again, you'll see here, I'm loading up a template from an external file and simply loading it in, and it's going to work the exact same way as my regular backend application would. So if I go back, it's the exact same application. The benefit of this is that if I want to start adding modules into the mix, I can very easily just pass in modules as dependencies, alias them, and start using them. I can very easily pull in dynamic dependencies